A resistor 5 ohm is connected in parallel with a resistor of R1 ohm. This combination is connected in series with an unknown resistance of R2 ohm, and the complete circuit is then connected to 50 volt DC supply. Calculate the values of R1 and R2 if the power dissipated by the unknown resistor R1 is 150 watt with 5 ampere passing through it. So the problem is described here, but the circuit diagram is not given. So let us draw the diagram. A resistor 5 ohm is connected in parallel with a resistor of R1 ohm. So a resistor of 5 ohm is connected in parallel with a resistor of R1 ohm. Okay. This combination, that is this parallel combination, is connected in series with an unknown resistance R2. Okay. This parallel combination is then in series with an unknown resistance R2 ohm. And the complete circuit is then connected to 50 volt DC supply. The entire circuit is then connected to a 50 volt DC supply. So this voltage is 50 volt. Okay. So we have to calculate the values of the unknown resistors R1 and R2. And the hint given is that the power dissipated by the unknown resistor R1 is 150 watt when a current of 5 ampere is flowing through it. When a current of 5 ampere is flowing through R1, so current flowing through R1 is 5 ampere, corresponding power dissipation is 150 watt. So that is the hint given. So let us start the solution from that hint itself. So power dissipated in R1. R1 is equal to 150 watt. So now what is the equation for power dissipation? So here we know the current flowing through it. So let us use the equation I square R. So I square into R is equal to 150, and here I is given as 5 ampere, so I square is 25. 25 into R is equal to 150. So here R is R1. So that means R1 will be equal to 150 divided by 25. That is 6 ohms. So we got the value of R1 directly. So R1 is 6 ohm. So now we know the value of current flowing through this resistance and the value of this resistance. Okay. So current and resistance values are known. So we can calculate voltage across R1. Voltage across R1 can be calculated, which is equal to, according to Ohm's law, voltage is equal to I into R. So current flowing through R1, that is 5 into its resistance value, that is 6. That is 30 volt. So this 5 ohm and this R1 ohm are in parallel. So voltage across R1 and voltage across 5 ohm will be the same. So voltage across this 5 ohm will also be 30 volt. So we can calculate current through 5 ohm. Current through 5 ohm will be equal to voltage across it, that is 30 divided by resistance V by R. So 30 by 5, which is equal to 6 ampere. So we have got this current as 6 ampere. So total current of this circuit will be 6 plus 5, 11 ampere. And this 11 ampere will flow through this resistor R2. Okay. So now we know the voltage across R1, that is 30 volt. So voltage across this parallel combination is 30 volt. Okay. Now, so total voltage of the circuit will get divided into 2, and a part will appear across this equivalent resistance and remaining across R2. So total is 50. 30 volt is appearing across this parallel combination. So remaining 20 will appear across unknown resistor R2. So we know the voltage across R2 as well as current through R2. Now value of unknown resistor R2. Is equal to voltage across it, that is 20 divided by current, that is 20 divided by 11, and on solving it we will get the value as 1.818 ohm. Okay, so we have got the values of the two unknown resistors. R1 is 6 ohm and R2 is 1.818 ohm.